Okay, today we're going to talk about reflections. And by the end of this lesson, you should be able to say, I can reflect points over the x-axis and the y-axis. So this red line here, this is the x-axis. And this line is the y-axis. It goes vertically. A reflection over the x-axis is a vertical flip. So that means I'm going to take this figure right here and I'm going to flip it over the x-axis. Notice what happened when I flipped it over the x-axis. It is completely turned upside down, or flipped upside down, and it is flipped vertically. Because when I go over the x-axis, all of my figure is going to go over my horizontal axis. So it's going to be actually a vertical flip going up to down. If I want to do a reflection over the y-axis, that's going to be a horizontal flip. You can imagine or put your pencil along the y-axis because that's the axis you're reflecting this figure over. And imagine that this figure, this arrow, needs to jump over that pencil. If you'll notice, it goes horizontally. In the original figure, the arrow is pointing to the left. But in the reflected figure, the arrow is pointing to the right. Think of when you look in a mirror. If you've got words on your shirt, in the mirror the words will be written backwards. That's a reflection. If I wanted to reflect a figure using the coordinate plane, all I simply need to do is redraw the shape so that it is reflected over the given axis. And in this case, we're going to reflect it over the x-axis. When I reflect a figure over the x-axis, it needs to be an exact flip in the exact flipped location. So if I were to fold my coordinate plane along the x-axis, my figure, my original figure, and the reflected figure will actually be right on top of each other. And let's look at what happens when I reflect this over the x-axis. Notice my original point was one space away from the x-axis, and we're going to call this point A. So my new point is also one space away from the x-axis. And since it's the new A, I'm going to call it A prime. And it looks like A with an apostrophe next to it. If this were point B, and I wanted to reflect it over the x-axis, I simply count down 1, 2, 3, 4 spaces to get to the x-axis. To find B prime, I start at the x-axis and continue counting 1, 2, 3, 4 spaces. This is B prime. When I reflect a figure, I also need to label my points. Let's look at point C. Point C is 1, 2, 3, 4 spaces away from the x-axis. So C prime needs to be 1, 2, 3, 4 spaces away from the x-axis. If I were to reflect this shape over the x-axis, I would simply look at my points and count 1, 2 to get to the x-axis. So I have to continue going 1, 2 away from the x-axis. If this is point A, this would be point A prime. If this is point B, 1, 2 to get to the x-axis, 1, 2 to go beyond the x-axis. B prime. Let's look at what happens when I reflect this figure over the x-axis. Notice the shape has not changed size or shape at all. It's only been flipped over the x-axis. even though this figure spans multiple quadrants, it can still be reflected over the x-axis because I take each point and count 1, 2, 3 spaces to get to the x-axis, 1, 2, 3 spaces to go beyond it. 1, 2, 3 spaces to get to the x-axis, 1, 2, 3 spaces beyond it. Now if I look at this figure here, because it's a reflection, it needs to be flipped upside down. So the slant is at the top of the original figure. It's going to have to be at the bottom of the new figure. And I can do that by counting 1, 2, 3, 4, 5 spaces to get to the x-axis. So go 1, 2, 3, 4, 5 more spaces to find my new point. And here is what my new figure should look like when I reflect it. And don't forget to plot your points or name your coordinates. Now let's try some reflections over the y-axis. Remember, a reflection over the y-axis is a horizontal flip. So my figure is going to have to jump over the y-axis. This is done the same way we would reflect some points over the x-axis. I take a point and figure out what's the distance from that point to the y-axis. And in this case, it is 2 units. So its reflected point would be 2 units away. Now, since my L is going to the right in the original figure, my L needs to go to the left in the reflected figure. And don't forget to label your points. Okay, so let's try it. Okay, so in this figure I have the slanted part, or actually this is called the hypotenuse because it's a right triangle. The hypotenuse is going down from left to right. So in my new figure, I know it needs to go down from right to left. I take a point. I notice it is 1, 2, 3 spaces from the y-axis. So I need to go 1, 2, 3 spaces beyond the y-axis to draw my point. And here is my reflected figure. Notice the length of this side is 2 units. The length of this side is 2 units. The length of this leg is 5 units. So the length of this leg also needs to be 5 units. These two shapes are exactly the same. It's just been flipped over the y-axis. And I've labeled my new vertices. Let's look at one more example. If I wanted to reflect this figure over the y-axis, I simply need to figure out the distance between the y-axis and each point, and then go ahead and replot that on the opposite side. Okay. Don't forget that each figure, or your new figures, need to be the exact same shape and size as the original. If it's not, I know I did something wrong. Notice the side here is 3 units, and the reflected corresponding side is also 3 units. And I've labeled my new points. Look here, this point is 3.5 because, or this coordinate is 3.5, because when I go to -7 and count up, I count up 1, 2, 3, and it's not quite to 4. It's right in the middle of 3 and 4, so the y coordinate in this case is 3.5. Now, WSQ in your notebook and complete the worksheet numbers 1 through 10 that you were given in class. Don't forget to WSQ and you can go back and rewatch any portion of this video if you need extra help.